Hi, everyone. My name is Abeeb Oladele. I am a senior mobile engineer and also tech lead at Stears. Um, um, Brief intro about me: senior mobile engineer, tech lead at Stears. Been, been a software. I've been a software engineer for 8 years now or more. I remember, I think 8 years now. So super excited to be here. Um, yeah. For today, we'll be talking about mastering the act of refactoring. I'm sure for most of us would have been in situations where we are trying to make a little change to our code base, and we've estimated that, oh, this particular thing would not take me more than 30 minutes. But to our surprise, when you get into the code base, you will find out that you would be doing more than you've estimated, or more than you expect. You'll be spending more time than you've than you expect to make that little change. And most of the time, that would be as a result of the way the code has been written. Maybe you've joined two functions together, and now it becomes hard to implement that change because you need to first separate the functional, what the function does before you make that small change. So that is where refactoring comes in. And that is why we'll be talking about techniques for improving code quality and also improving code maintainability. So yeah, let's just dive right into it. Um, when it comes to talks like this, people will first start with, oh, what is this refactoring that you're coming to talk about, right? So we'll just define refactoring. Refactoring is a systematic process for improving code without adding new functionality. So basically, you are just, when you say you are refactoring, you are not adding new feature, you are not tweaking anything, you're basically just improving the way your code is, which is also you just transforming your code from a dirty code, the state of your code from being dirty to being clean, and you improving your code design to it being simple to maintain, to add new features, to extend whatever that you want. So you might ask me, how do you know that a code is dirty? Another word for dirty code is when people say, oh, in quotes, spaghetti code. That means everything, all those things are not, your code is not well engineered to have separation of concerns. Everything is just tied up, and you make changes here. For example, you make changes to user login, and then it is affecting how you want to transfer money. That's a sign of spaghetti code. That means, oh, you've tied something from login to ability to transfer money, which is not supposed to be so. So that's a pure example of a clear example of dirty code. So in definition, dirty code is just a messy code that is written as a result of maybe inexperience on the part of the engineer, multiplied by tight deadlines from stakeholders, maybe even from pressure from users, pressures from um, stakeholders like product managers. Also code mismanagement. You want to write a new feature and you just like, let me just add this function here. That means that's just clear mismanagement. You're mismanaging. You're not putting in a lot of thought process into how you're writing your code. And then also some nasty shortcuts that you must have taken during development process. Sometimes you have to take nasty shortcuts because you are placing priority over the speed of delivery. Um, you are placing priority on your speed of delivery over the quality of the code that you're writing. An example of situations like that are, for example, you work in a fintech startup, and you have a little bug where the company is losing like 15 error per second. You want to your first line of action is just to get it solved. You wouldn't want to worry about, oh, is this code clean? You want to stop the loss at that point. So those are stuff that contribute to making your code dirty, right? So now if you are saying, oh, refactoring is the act of transforming your code from being dirty to clean. Now, what is a clean code? Clean code is just code that is easy to maintain, easy to read for anybody who understands the language to figure out, easy to read it, easy to understand, and most importantly, easy to maintain. Because when you have a code that cannot be maintained, that means the code cannot even improve. You can't you can't add new features, you can't make changes and stuff. It's just there. It's like it's like a dead end, right? So having a clean code makes your development predictable. You can estimate the amount of time that it will take you to make a particular change. You can even estimate the amount of effort that you need to put into making that change. And above all, having a clean code helps to increase the quality of your resulting product. So yeah, so those are like the definitions. Now you would ask me, why should I refactor? What is the importance of this refactoring? To be honest, the main purpose of refactoring is for you to fight or pay back your technical debts. And technical debt is just those trade-off that you make when you want to place priority over delivery rates, your time of delivery, over the quality of the code that you're writing, due to a lot of external factors, maybe deadline from stakeholders, and it might even be a skill issue, right? So you just want to get things to work before you optimize, and all those kind of speed things, you need to iterate fast. So that is where technical debt gets introduced into your code base. So the main purpose of refactoring is to fight technical debts, right? And then when you refactor, it helps to, just from the definition, it helps to transform a mess or dirty code into a clean code and simple design. Other reasons why you want to refactor, apart from not being able to move forward, make changes, is for you to improve code readability. You want, most engineers, even myself included, you write a code you go back to a code that you've written for maybe 2 years ago. And if it is not well written, you start to look like, oh, okay, who wrote this? Who wrote this? I don't even understand. I need to read it again to get context of what it does, even though I'm the one who wrote it like a couple of years ago. But if it is well written, if the code readability is great, you can easily read it and understand that and get enough context to move forward. Other reasons includes like enhancing performance. You want to refactor, for example, you have a feature that is taking 2 minutes to upload a profile picture, for example. Sometimes you want to refactor to optimize that process, to say maybe you'll reduce it to like 30 seconds to less than 30 seconds. So you want to do some refactoring. Also, you refactor to facilitate debugging and testing. Sometimes you have bugs and then you need to debug. That is when your eye will clear to say, oh, we did not properly write this thing, because it's even hard for you to debug. So you want to refactor just to make your debugging and testing seamless, as easy as possible. Also, like I mentioned, one of the main purpose of refactoring is to fight technical debts. How do you fight technical debts? Every code base in this life has technical debts. The more you write new code, the more you add code to your code base, the more technical debts it will bring. No code is 100% perfect, so you want to keep refactoring to reduce technical debts. And then also, last but not the least, you want to refactor because you want to prepare for future changes, or you want to prepare for scaling. Like, oh, okay, we know this particular feature works now that we have thousands of users. What happens for when we have millions of users? You need to start you need to start from when you have thousands of users. You need to start preparing and refactoring, optimizing to make sure that by the time you get to 1 million users, you'll be in a good place to add. Example of that has happened to us was before the elections, we've always had like tens of thousands of users coming, 100,000s coming and go. But during election, due to the election products that we had, where we were providing real-time data on Nigeria elections in 2023, we had millions of users. If we had not been prepared for that, it would have been down for most of the election period. But because we've done a lot of refactoring, we've prepared for scaling, we were able to handle millions of traffic coming to our website to get election data. So yeah, now you know what refactoring is. We know the importance of refactoring. Now, okay, I want to refactor. How do I know when to refactor? Right. You cannot just have a feature. You have feature requests or you have tasks to do and you just say, oh, let me abandon that and it's refactoring, only refactoring that I want to do. No, you need to know the indicators for when to refactor. So for me, the first indicator for refactoring is the rule of three that you use. When you need to write a function, for example, or a function, let's put it that way. Like basically you need to write a function to add two numbers. If I'm writing it the first time, just do it anyway. But now you have another feature to add more than one numbers, or even another feature to solve simultaneous equation. You know you'll be doing a lot of adding two numbers here and there, subtracting. If you have to do it the second time, write almost the same thing, you need to cringe to write it the second time. You need to feel uncomfortable to write it the second time. But when you now have the third time that you want to write something like that, that is a clear indicator for you to start refactoring, because you cannot afford to having like duplicates functions doing almost the same thing at the in your code base. So you want to start refactoring at that point for it to accommodate whatever use cases that you already have. So yeah. Another indicator is the Boy Scout rule. I don't know if we have anybody who is a Boy Scout. Yeah. The Boy Scout rule is to always leave something better than you found it. So applying that to your code is also an indicator of when to refactor. When you see a code, maybe you are writing new feature, you are making new changes, and then you go through a code, because we learn every day. Being as a technical person, you learn every day. You see codes that you've written before and they just look like jargons to you. That is growth. That is because now you know you are aware of better ways to do things. So when you are going through a code, maybe you're just going through it in your leisure, or you just want to add new features, right? You go through a code and you see, oh, okay, maybe this if statement, we can convert it to switch, right? That is an indicator for you to just do it at that point. Another time is, oh, you're fixing bugs. Most times, for a large chunk of time, when you're fixing bugs, they would require you refactoring some parts, because bugs, right? That means you've written something that is a misbehavior, right? So most times you have to refactor to fix a bug. So that's another indicator. Another indicator is when you're working in a team and you want to do code review. You see maybe even your own pull request or pull request from another teammate. They are maybe, for example, you need to iterate. Maybe they just want to iterate through a list to get numbers that are even numbers, right, from a list of numbers. And a teammate might go through the approach of writing a for loop. When reviewing, you might just think that, depending on the context of the code, you might think that, okay, maybe writing a mapping that list would be a good approach. So those are opportunities where code refactoring comes in. You see somebody make a new change, and then during code review, discussions will come up, indicate reasons will come up to refactor as well. And then last but not the least, when you're adding new features. For example, I have an existing functionality to add two numbers. If I need to add, if I have a new feature request to add 4 numbers together, 5 numbers, or dynamic length of a list, that is a good point for me to refactor the existing one away from just taking 2 parameters, adding 2 numbers, to maybe introducing a list parameter to it, and then adding the sum of the element of those lists. So those are the indicators of when you want to refactor. Then now we know why we need to refactor. We know when to refactor. Most importantly, we need to know the principles that guides refactoring as a whole. So we'll be talking about that next. One of the principles of refactoring is this. There's a popular phrase in software development, which is keep it simple, stupid. You don't need to overcomplicate your function. You don't need to overcomplicate your code flow. There's a thing called divide and conquer. When you have a large chunk of a large problem, you try to divide it into simple chunks, and then make them interact with each other some way, or link them together to solve that data. So keep it simple as much as possible. Dry principle, do not repeat yourself. When you know that, this also ties into the indicator of when you're doing something first time, second time, the third time is becoming a repetition. Refactor. Please try as much as possible. Try as much as possible not to repeat yourself. If you have a function that does something in a class, and then you have another class that needs a function that does the same thing, maybe you need to move that function out, just abstract it out to an utility class, for example, so that both class can make use of it. Another one is the single responsibility principle, which is like one of the core elements of a clean code. Make sure that each of your function does only one thing. If you see a function that does more than one thing, for example, I want to solve a simultaneous equation, there are a lot of processes. You want to add numbers, multiply, subtract, and whatnot. You want to extract those kind of things out. You want to make sure that your function does one thing and only one thing only. You don't want a function that would, it can carry my chair, it can carry my table. No. It is best to separate them to make sure that, okay, all this function does is to carry my chair. That will be it. Then when you are refactoring, you want to ensure that you're making the changes incrementally and in small chunks. You don't want to see a 1,000 line of code and think, oh, I can refactor it to 20 in one go, to 20 line at a go. You just be introducing yourself to a lot of problem. So you want to make your refactoring in small chunks and incrementally. Oh, okay, I see an opportunity to refactor this 4 line to 1 line. Do that first, and then another opportunity. That is how you go, and then before you know it, you've refactored a 10,000 line of code to 5,000, depending. Right. Okay. So the last one is continuous integration and testing. You are making changes in incrementally and in small chunks. As you are making those changes, you want to be testing. You want to do your integration testing to make sure that your refactoring does not break anything or does not introduce a bug. You want to write unit test, integration test, end-to-end test. You want to test as much as possible. because in the process, refactoring can be quite tricky. In the process of you wanting to optimize, you wanting to improve your code readability, you might be introducing more bugs into your code base. So you want to do it in small chunks, and then you want to test as you are doing it. You want to test incrementally as well. Now we know why we want to refactor, when to refactor, and then the principle that guides us. Okay, what are the common techniques for refactoring? How do I recognize, what are the techniques that I can use to recognize, that I can use to refactor, right? Those techniques are divided into a lot depending on what resources you are using, what kind of book you're reading, what resources you're looking at. But for the purpose of this call, I like to keep it basic and small so that we don't spend all our time here. So I'll be dividing them into two, and then there are more that I would likely share later. For composing methods, we have extract method, where you want to extract part of your code away from part of your function away to be another function or to be another variable. Inline method, like an if and else that is taken, or just two if and else. You can convert it to ternary operator or even make it an inline thing, an inline checks. Substitute algorithm, replacing magic numbers and strings with constants. This last one is something that I've seen in a lot of code base, where you see people just you you want to check for something, and then you're doing something, for example, like, oh, if sex is equals to 0, or if age is equals to 18, maybe you are building an adult rated product. You're doing if age is equals or less than 18 or 16. That is a business requirement. You do not just want to introduce the 16 as just introduce it just because you can. You want to move it to a constant, or maybe an environment variable if you want to optimize further for future changes. You want to move it to a constant where you just need to, if the requirement changes, you just need to go to the constant and make that change. And you don't need to go into your code base and be looking for where you've written 18 before. So yeah, another major classification of refactoring techniques is simplifying conditional expressions. You have this one is around having conditionals, like maybe in if and else, in while loop, and you look for ways to make them more readable, and then you make them like take less line. Under that, we have decompose conditionals, we have consolidate conditional expression, we have remove control flag, we have replacing conditionals with polymorphism, and then introducing assertion. For replacing conditionals with polymorphism, maybe rather than doing if John object dot name is equals to John, blah, 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 or if an object is equals to one property that you're using to check the type, maybe you want to use polymorphism as like part of your object-oriented program. You want to use polymorphism to create different type of DAO objects with different behaviors, right? Introducing assertion, maybe, for example, you have a stage, a line in your code flow where you want to make sure that all the variables that you want to use are not null. They have value. They are not none for Python people or undefined for JavaScript people. Rather than using if and else, or if to make sure that, oh, you run this line of code, maybe when you know that it is compulsory for these variables to have values, maybe you want to use assert at that point to make sure that, oh, okay, if this variable do not, there's no point trying to do any if and else, just break down, right? And then next I'll be showing examples of, I'll be showing some of these refactoring techniques in action. So for extract method, if you look at extract method, this left side is basically printing when a user or something is owing an outstanding, maybe outstanding bill. So the first one, you see that, oh, it is printing banner first, which is print owing, is printing banner first, then printing the name, and then printing outstanding. In cases like that, printing banner is doing one thing. You also want to extract the name, or like having just the comment of print details. Why not just extract it to another function for it to be, oh, print details and does any printing, then you can. While looking at just print owing, you can easily read it to see, oh, okay, if I want to print owing, I print banner first, and then I print the user details first. The user details next, rather than saying, oh, okay, print banner first, or print name, print outstanding. Now, if you want to write, if you need to add, maybe you print the user's address or something, you just need to come to print details and you've added it, you've got. Right. Oh, okay. Inline method. Inline method is just the technique where you use to break things down into inlines. I hope that makes sense. Like break like multiple line of code that you've separated to like multiple lines. You want to bring it to a particular line. For example, if you look at the left side, this get rating is saying, oh, okay, return to if this function, if this function is check is true. If it is not, return 1. So rather than having this function just doing this particular one, there's an opportunity for us to just bring the checks here. In a situation where this the more than 5 late deliveries function does more than one thing, maybe it has more than one line and all that, that would make sense for us to have it in a function. But if it is just a particular line, it does not cost us to, it is more readable for us to have it as an inline, rather than whoever is reading the code having to now start looking for, oh, I'm looking for the more than 5 late deliveries function. And when they've gone through the whole stress of finding it, they now see that, okay, it's just one line to check if it is more than 5. Okay. Replacing magic numbers or constant. Like I explained earlier, people would do just, oh, when discount is this code. Imagine a situation where you've used this kind of condition, you've used it in multiple places in your code base, and now tomorrow you get a request to change it from discount is equals to 10 to 20 to discount 20. That means you have to start going into your code base, looking for everywhere that you've used discount is equals to 10, sorry, discount 10, now changing it to discount 20. But when you could have used a constant where you just come here and your code does not know, oh, okay, your code does not know much details about the changing business requirements. Right. In a situation where, oh, you are using the code on the left side, and you've used this condition in multiple places. If you're able to change 9 conditions out of 10, that one that you forgot will still be a bug and might cause a lot of issues for the business. So yeah. Next one is the substitute algorithm. You can see from the left side, this function basically is looking at a list of people here, and just checking, or if the name is done, return done. It's basically checking if the name, checking for the name and then returning the name. This is kind of an amateur thing. If you look at it deeply, an opportunity to refactor would be, oh, okay, I want to check the name, and I'm basically just returning the name. So why not just, oh, we have the list, and then I trade through the list to say, okay, return people if people is in this candidate. Just to say, okay, maybe we have like 100 people, we want to get 4 out of it, or we want to print 3 out of it. You can make those 3 a list as well, and then run checks to see if it contains. So that is substitute algorithm. Just looking at it, you can see that the right side, the code on the right side is better in terms of readability, and even in terms of like length of lines of code. Is just simplifies it. Yeah, another one is decompose conditionals. So you have you have conditionals that does, when Abeeb is male, then, or when Abeeb is less than a particular height and Abeeb's skin color is whatever. That means you're having like composite conditionals. That means you are composing those conditionals. So what you want to do in that case is to extract those conditionals.
It might be person. But while we wait for it to I did work on.
Hello?
Hey,
Hello?
I mean, we can hear you. Can hear you.
Sorry, did you guys lose me for some time?
Yes, we did. Right now, you're not sharing your screen.
Okay, sorry, please let me share my screen. Please let me know the points where.
I think
Was
you're
it this
working. No. The next slide.
this one?
Next slide. Yes. You already started working on some features of like a person, like if they meet a certain.
Okay, sorry. But is it this screen?
Yes, that is correct.
Okay. Right. Okay, so I was talking about the removing control flags, right? We've all been guilty of using variables to control our for loop or our while loop, right? For example, in for loop, you can say, oh, okay, when everybody's even guilty of this, where you say for I is equals to 0, blah, blah, blah. And then you want to break out of that loop. Most of us have been guilty of situations where we'll say, okay, if I is equals to 1 thing, cancel this loop. Or don't use, no, in the for loop, you want to say, oh, if I is even number, if I is divided, modulo 2 is equals to 0, that's how to check even numbers. Run this operation. But then we can use, it is better to use control keywords, if I like to put it that way. And control keywords are break, continue, return, rather than using Boolean variables to determine or when to break out of a loop, when not to do anything in a loop. We can always use keywords break, continue, and return to control that. Okay, now we know how to refactor, we know where to refactor, but then knowing these things are not as important as doing it. And if you work in a team, anytime you want to refactor, you are most likely going to be challenged and also expose yourself to some risk. Although refactoring comes with a lot of advantages, but then there are challenges to it as well, and then there are risks to it. So one of the risk, in fact, not one, the major risk of refactoring is the fact that you can introduce new bugs to your code. You can refactor your code and then, you give yourself thumbs up on, this code is better in terms of readability, or we can maintain it until you push it to, you release it to your user, and then you realize your new and shiny refactored code has introduced bug into that. And how do we mitigate that kind of risk? Is by doing one of the core principle of refactoring, which is continuous integration and testing. You always want to test as much as possible. You want to test your refactor code as much as possible. That way you'll be able to mitigate introducing new bugs to your code. Now, another one is over refactoring. Don't just refactor for the sake of it. Over refactoring and then premature refactoring, like I like to call it, is also another risk. Sometimes you refactor, and then because that particular part of the code base is not even ripe for refactoring, you refactor and do a lot of work, and then in the nearest future you get a request and you find out that the refactor that you did couple of months ago is now hindering you from making a new change, right? Depending on how you refactor it. So a way to mitigate that is to focus on areas that would benefit you the most. You don't want to stress yourself too much on areas with little benefits, right? You want to run an effort outcome ratio analysis on it to know, okay, if I put in this particular amount of effort to refactor this part of the code, what is the corresponding benefit, right? Or what is the ROI for this effort? What is the return on investment for this effort? How much benefit do we get on spending a lot of time refactoring this part of the code? And for people like us who work or people like you too in future who work for companies with bunch of stakeholders, most of the time you will get resistance. Like, you'll be in a point where, you tell the business people, we need to refactor this part of the code base. We need to pay this technical debt and stuff to enable us move faster. You are still going to get some resistance and no go on doing refactor, because the business and stakeholders are more the business and stakeholders they care a lot about what you put out. They care about, what will the user see? In most cases, when you are refactoring, the user does not see anything. The business does not see anything. It's the technical people who are working on the code base that would know, okay, this is the benefit of what we're doing. The stakeholders are more concerned about, the product, new features we're putting out, the product and stuff. They do not really concern themselves around the code base. So you are most likely going to get a no-go in most cases. And the way to mitigate that is by educating your team members and stakeholders on the long-term benefits of refactoring, right? In my experience, I've been in situations where I've had to organize a call to get people on the call to educate on, okay, if we don't do XYZ, to do this. By the time you want to, a lot of time, right? Because of the past business requirements, we've done this and that. Now, if we want to do XYZ, it is going to take us a large chunk of time if we do not refactor now. So a way to mitigate that is to educate people, educate your team members, educate stakeholders on the benefit of refactoring. refactoring. Once you can paint the picture properly, you would be able to mitigate that risk. So yeah, Q&A. Hi guys. Hi Emeka.
Hi, thank you, Abeeb. I think there's a question in chat right now from Fems.
Okay.
Fems, do you want to unmute so I can actually ask your question so Abeeb understands exactly?
Okay. Well, I just said, you mentioned something about the for loop scenario where in terms of breaking the for loop, there's sometimes you need conditionals to break out of the for loop. I don't know. That was
Yes.
the question I was trying to relate to.
Yes. There are times where you need conditionals. Like I painted, let's say, for example, you want to call a function when you are iterating through a for loop and you want to call a function where for even numbers only. Do you get? So rather than writing, oh, if this one and then putting your code into it, you can write if number is even and whatever, if number is even, and then just do continue or just do break rather than wrapping it in an if and else and doing all those things. I hope you understand. Okay. All right. Thank you, Femi. Siri.
Thanks for that question. If you do have questions, if you do have more questions, feel free to raise a hand, share in chat. This is the time when we are taking questions. So we're going to give a few more minutes to see if folks have questions or comments. So I see comments from Mohammed in chat. He says, thank you for sharing this experience with us and also one.
You're welcome, Mom. You're welcome, Labaka. Oh, okay. Ebonlua. Yeah, so decomposing is basically when you have, for an if statement, for example, you have you want to write an if statement that has conditions that are changed together. Like I painted, let's say, for example, you want to identify a person object, like Abeeb objects, for example. You might want to say, oh, if name is equals to Abeeb and surname is equals to Oladele and height is equals to blah, 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 you know, you are already having chains of conditionals, right? So in scenarios like that, you are likely to introduce bugs, or even it hinders readability when, or in my head, I'm reading your code and then now I'm having to translate what the condition would. I'm trying to calculate what the conditions, those composite conditions will translate to, right? So what you want to do in such scenarios is those composite conditions, you want to move them to a method where you can properly know, okay, this is a Abeeb method, this is what it does, this is how it checks it. And for example, where that comes handy when you do something like that is, let's say now the program does not identify Abeeb again, maybe because of a bug or something. You can easily go to, during debugging, when you are debugging, you can easily go to that function to say, okay, let me comment out that function and do return true first. And see that, okay, even when it's true, it's not running this thing. That way, you know that, okay, the if condition is being met, but maybe the line of code that you have in your if block or the function that you have in your if block is the one not executing well, rather than you wasting time to try to compute what those conditions will translate to. All right, you're welcome.
question, everyone. If you do have questions, we have until the hour to keep taking them, so if you keep sharing them. But before, okay, I think there's a question right now from
Okay. Oladipupo is asking, what of something like a function that handles all validations? Do I need to decompose? What do you mean by handle all validations?
Okay, can you hear me?
Yes, I can hear you.
Yeah, so like a form, like let's say like a form, like for example, maybe like a formic form or something like that. So
Okay.
like before like a user can go to like to the next screen, for example, or to the next, or so like submit the form entirely.
Yes.
So like a validation function that like handles everything, like something like that. Do I need to like decompose it? Yeah.
No, that's a function already. I don't know how formic form works, but what I am thinking in my head is when you write, for example, you guys are familiar with Python. So when you write a Django, when you have a Django application, for example, and you have a form, the check is basically, oh, form dot is valid. Right. If if the way to validate a formic form is where you check, oh, when name field is filled, this one is filled, one thing is filled, maybe you might want to create a separate function to move it. But if it is just, oh, form is filled, I don't think you need to do that.
All right, thank you.
You're welcome.
thank you for that question. For, while we allow other folks to answer or ask more of their question.
Okay. Yeah, I think there's one more question. Right. Yeah, there's one more question. What is your first point of contact when dealing with legacy code you have no idea about? To be honest, my first point of contact is to have idea about it. Right. You can, it's straightforward. It's quite straightforward. You can't change what you don't know. So my first point of contact is to get a hang of the legacy code. It's always hard. It can be overwhelming, but it has to be done. Right. So try to contact the person. In most cases, you are there because they are unable to contact the person. Yes, that's just it. So the hard thing to do is to do the hard thing first. Get to know how the legacy code base work, and yeah. But if you don't have, okay, a shortcut that I use is, if you don't have the time and patience to first have an idea of the code base, what I do most of the time is start to look at the unit tests and integration tests. With tests, when you read what the developer is trying to, what the code base is trying to test for, you get a quick context of what it is doing. Right. If you get an integration test that is testing, or an end-to-end test that is testing a user login flow, for example, if you follow the end-to-end test, you would know, okay, or input email, password, or click button to log in, then from there. And even when you don't have full context, you would not have full context when you are working on a legacy code. As you are making those changes, as that speaks to the principle of refactoring, small and incremental changes. As you are making small changes, you are also doing continuous integration and testing. So as you are making those changes, you have to run all your tests to be sure that, oh, what you changed for your login mechanism has not affected bank transfer. So you want to test as, at least when you make that change, even if you don't understand the full context, you make that change and then you run and you see a test failing. That's the point where you know, okay, I've broken this test. Let me go and see why the test is failing, and that will point you to what you are doing wrong. But most importantly, try to familiarize with the legacy. It is no longer legacy when it is your problem. Okay, so while we wait for other questions, if you guys have, I have references here for where you can learn more. These are like references that my go-to references for refactoring. The first one is a website dedicated to refactoring. Most of the samples that I showed that were in white were gotten from refactoring, but it covers a whole lot of things, even for refactoring techniques, for when you want to set up a coding style. There are areas there that shows you stuff, maybe rules to enforce, like when a class is too long, all those kind of things that would help to save your team and code base from incurring a lot of technical debts. The second one is a book, Refactoring, Improving the Design of Existing Code. So maybe somebody like Oluwafemi Sere might want to have a look at that, considering that you asked about legacy code. So this book focused more on like refactoring existing and old code base. Then last but not least, Wikipedia. I know this site can look boring sometimes because it's a lot, but there are a lot of gems in there as well. So yeah.